What if the most groundbreaking image in human history didn't come from Hubble, James Webb, or Perseverance, but from an old probe? Voyager 1, now more than 14 billion miles from Earth, has just sent back a photograph from the edge of the solar system. No one expected this tiny machine, launched 46 years ago, to change how we view the cosmos. The image arrived quietly from NASA's Jet Propulsion Laboratory, captured during Voyager 1's journey through the heliopause, the boundary where the solar wind ends and interstellar space begins. At first glance, the image looked like nothing more than static, green and purple pixels scattered across a black background. But engineers at NASA and ESA used machine learning and advanced filtering to process the faint data. Then something extraordinary emerged. Filaments, like glowing cosmic tendrils, appeared, stretching across the frame. This was no mere, pale blue dot. It was something new, luminous, and alive with structure. Near the stars, the filaments resembled magnetic field lines or interstellar dust streams pushing into our solar neighborhood. Since 2012, when Voyager last looked this way, the scene had changed. Voyager's instruments also recorded sharp spikes in plasma waves and cosmic ray flux, indicating active interactions at the boundary. This wasn't a static picture, it showed motion. Something dynamic was occurring between our solar system and the stars beyond. NASA had revived Voyager's old imaging systems with updated software, commanding them to capture one final glimpse before silence sets in. Each exposure lasted up to 4 hours, later stitched into a single frame. This isn't just an image, it's a mystery. So, what are we seeing? One theory. Magnetic filaments formed by the solar magnetic field merging with larger galactic structures. Dr. Leila Moreno from Chicago believes charged particles spiral along these tendrils. Another idea from Cornell proposes that glowing dust grains are energized by solar wind collisions. A more radical suggestion? The filaments could be interactions with dark matter. Dr. Amara O proposes that axion-like particles, hypothetical dark matter candidates, could be converting into photons when passing through intense magnetic fields. These aren't science fiction. They're grounded in real physics and backed by Voyager's live data. Then, things got even stranger. A recurring hexagonal pattern appeared within the image. Almost perfectly symmetrical, these shapes puzzled researchers. Hexagons are rare in space but not unheard of, like the mysterious formation on Saturn's North Pole. But here, at the heliopause? Never before. What's more, the hexagons weren't aligned with the magnetic field. They lined up with Voyager's own spin axis. Was this a motion artifact, or a real plasma structure? Some propose these are reconnection islands, regions where magnetic field lines snap apart and rejoin. Imagine a cosmic honeycomb, stretching billions of miles. Others took the mystery further. What if these are artificial? Mega structures designed to channel interstellar plasma flows? While there's no evidence of alien origin, the perfect repetition of shapes has ignited debate across online forums. Still more fringe theories suggest quantum effects. That what we're seeing could be quantum resonance patterns, visible only in high-contrast zones where fields overlap. Or perhaps it's all a glitch, an artifact of our reality. Dr. Nguyen Tran suggests this could be a rendering error, in a simulated universe. Too speculative? Maybe. But the image is too precise to dismiss. Then ESA's New Horizons team joined in. Using their own filters, they enhanced Voyager's data further, and found a second filament. Fainter, broader, tilted exactly 60 degrees from the first. At first, it seemed like an error. But repeated analysis confirmed it was real. Mapping both filaments revealed 12 distinct radial lines, like the spokes of a giant cosmic wheel. One set was narrow and bright. The other, dim and wide. They resembled harmonics from a vibrating drumhead. The pattern spanned 80 degrees of the image, with alignments too exact to be noise. ESA researchers now believe it could be magnetohydrodynamic resonance, a kind of plasma, ringing, at the edge of the solar system. Like ripples in a pond, created where solar and galactic winds meet. One ESA physicist called it, "the heartbeat of the solar system," captured faintly in Voyager's final view. No model, not the Parker spiral, not Voyager's known path, predicted these structures. This discovery could change how we understand the Sun's interaction with the galaxy. The solar system may not simply end, it may resonate, even sing. From filaments to hexagons to clock-like spokes, Voyager 1 continues to defy expectations. With only 68 kilobytes of memory and a 23-watt transmitter, it's delivering treasure from the void. Old missions don't lose value, they gain power when paired with new tools. Noise we dismissed in 2012 has become a message in 2025. We are no longer flying blind through space. We're seeing it, finally, with new eyes.